Cool. So hi everyone. So I'm Maxime. I'm part of the smart contract team, and today I'll show you how to build the yield donating strategy. So yeah, so here's the workshop agenda. So we'll start by introducing you to the 4626, the foundations, because the yield donating strategy are 4626. Then I'll show you the differences between the normal yield strategy and the Octant yield donating strategies. Then we'll go into the delegate pattern. I'll show you two of the most important functions of yield donating strategies. And then I'll show you all the required functions that you need to implement when you are building a yield donating strategy. And then we'll go into the optional ones. And at the end, I will actually build a very small Aave v3 yield donating strategy. So here are the prerequisites for this presentation. So you should be familiar with Solidity. You should also know about 4626, even though I'll kind of introduce you to it, but still, if you're not familiar with it, I strongly encourage you to actually dig it. Then we'll go into understanding the minimal proxy pattern in smart contracts, because our strategy are very, very similar to that. And then I'll go into the basic, then you also need to understand DeFi protocols. So 4626, it's a tokenized vault standard. It's a standardized interface for yield-bearing vaults, where users deposit asset like USDC, and then they receive vault shares in return. The vault deploys this asset in generating yield sources, and the share price appreciates over time. So here are the main functions. So you have the deposit and mint function, which are basically the enter the vault function, where you will deposit your assets. It will deploy your asset onto a yield source. You also have the withdraw and redeem function, which are the opposite, where you will actually withdraw your asset from the strategy and from the yield source. And on the right, you have the conversion function, which are the convert to share function, where you pass the number of assets, and it will actually give you back the equivalent number of shares, and the opposite with convert to asset function, where you pass the share number, it will give you back the equivalent number of assets. And you have other functions. I won't go into them, but you have preview function, limit functions, and also state functions. So now we'll explain you how yield donating strategy are different from the normal yield strategies. First differences is the yield distribution. In normal yield strategies, the price per share increases over time, so the user shares appreciate. While in the donating case, the price per share always stays one-to-one. What happens is when there is some yield generated, we're actually minting new shares and giving them to the donation address. In terms of balance tracking as well, so in normal strategies, the user balance appreciate as yield increase. In the donating case, it stays constant. So if you deposited 100 USDC, you at most you would be able to withdraw 100 USDC. And what happens is with this yield generated, we'll just mint new shares and give it to the donation address. And one of the differences as well is the loss handling. In normal strategies, when there is a loss, basically the price per share reduces. While in our case, we'll try to first burn the shares of the donation address, so that the depositor are not impacted by the loss. So here's an example with numbers. So let's say in a normal strategy, you start with a state of a total asset of 1,000 USDC, a total supply of 1,000 share. So the price per share will be 1. After you generate 100 USDC in yield, the total asset becomes 1,100. The total supply stays the same, so it's 1,000 shares. Then the price per share increases to 1.1. So someone that had 100 shares, basically, which was worth 100 USDC before, now is worth 110 USDC. So he made a profit of 10 USDC. While in their case, with the same state, initial state, after there is 100 USDC generated in profits, the total asset becomes 1,100. However, the difference with the normal strategy is that the total supply will also increase to 1,100. So the price per share will remain 1. What happens is there is a new 100 shares that are donated to the donation address, and the user still has 100 shares and still can withdraw 100 USDC. Now I'll teach you about the minimal proxy / delegation pattern, because that's our strategy working actually. The idea is that basically the difficult rationale, like for example the 4626 rationale, you don't need to care about it. What you only need to care is focus on the interaction with the yield source. So here is a minimal proxy. As you see, it's very simple contract. It has implementation address and it has a fallback. And every call that is made to this contract, which basically goes to the fallback will delegate call to the implementation contract. So if the implementation contract was the one on the right, which has like two functions, set value and get value, and two storage variable, value and owner. If you were to call on the minimal proxy set value, it will trigger the fallback. Then it will delegate the call to the implementation contract. It will execute the logic of the implementation contract, but it will execute it in the context of a minimal proxy. So it will actually update the minimal proxy storage. And this is how it's done as well in our strategy, where basically you have the base strategy, which has a fallback function that delegates the call to the yield donating contract. So your custom strategy will inherit this base strategy contract. And in your custom strategy, you would just need to implement a few functions like deployFunds, freeFunds, and harvestAndReport. And you would not need to implement deposit and withdraw. I mean, you would not need to implement the 4626 function because they're already implemented in the yield donating contract. Then there's like some other function that are implemented there, like the yield management functions, where you have the report function and the handleLoss protection function. And one thing you need to know is that the yield donating contract, sometimes we make callback to your strategy contract. For example, it will make callback when you're trying to deposit fund. It will call deployFund on your strategy contract so that it knows actually how to interact with the yield source. And same for freeFund when you're trying to withdrawing. And same for harvestAndReport when you are calling report on the yield donating contracts. So here's the execution flow. If your user calls deposit on your strategy contract, it will not find it. So it will go to the base strategy fallback, which will delegate the call to the yield donating deposit function. And the yield donating contract will call back your strategy deploy fund function so that it knows how to actually deploy the fund to your source. Here are two functions that makes our strategy different. So you have the report function that I'll show you and the handleLoss protection function. So report function, this is a simplified version, but as we said earlier, the report function we call harvestAndReport on your strategy, which will return the total new assets. So the assets that are actually in the yield source and the one that are currently hidden in your strategy. And then what it will do, it will compare the total new assets with the old new assets. If the total new asset is superior to the old new asset, it means we have a profit. So it will convert this profit to shares and it will mint it to the donation address. While if the new total asset is inferior to all total assets, then we have a loss and it will call handleLoss protection. So here is the handleLoss protection. handleLoss protection is optional. So you have an enabled burning flag for that. What it will do basically is take the amount of loss, convert it to share. Then it will compare how much you need to burn with the actual balance of the donation address. And if the share that you need to burn is higher than the donation address balance, then it will burn the entire balance of the donation address. If it's less or equal than the donation address, it will burn what it needs to burn, basically. So now I'll show you the function that need to be implemented and the optional one. So the three functions that must be implemented all the time are the deploy function. So that deploy function, deploy funds, sorry. So that deploy funds function is called when you are trying to deploy fund to the yield source. So yeah, if your yield source is a 4626, it will basically call the deposit function. You have the freefund function, which is basically called when you're trying to withdraw funds. And you have the harvest and report function that we saw earlier, that is basically giving back the total asset that you're actually managing. And here you have the optional functions. So you have the 10 function. So 10 function is a privileged function that allows you to deploy fund to the yield source without going through the deposit and min function. 10 trigger will tell whether you are allowed to call 10 or not. Emergency withdraw is also a privileged function that allows you to withdraw funds from the yield source. And you have available deposit function and available withdraw limit function, which basically will make calls to the yield source to know whether there is a maximum deposit you can deposit or a maximum withdrawal you can withdraw. And now I'll quickly show you how we can implement Aave v3 yield donation strategy. So we have a starter pack repository that will be available after the workshops today that you can use to deploy, to basically build simple strategies. So here we are. So this is the README of the repository. I've already done all this so we don't lose time. I already set as well the environment variables, but just so you know, the asset address is actually the asset that you're trying to deploy to. The yield source, so in my case, it would be USDC. The yield source is actually the address of the yield source. So in my case, would be like the address of the pool of Aave. And then you need to set the RPC URL because in our repo, we're actually doing fork test. So yeah, we need that. So here is the contract that you need to modify, the yield donating contract. And we'll start by the deploy fund function. So the deploy fund function on Aave, basically it will be the, wait, I'll show you, it will be the supply function. There you go. So I will add it to my yield source interface. Okay, because I've done it before. So basically we call supply on Aave, where the asset will be the address of the asset, the amount, and on behalf of will be this contract address, and the referral code is 0 because it's actually not activated. And then we go to the next function that must be implemented, the freefund function that will be called when you are trying to withdraw funds. So on the pool, on Aave pool, it will be the withdraw function. So we'll withdraw this asset, this amount, and we'll withdraw it on this contract. And now we'll take care of the harvest and report function. So harvest and report should return all the assets that you are currently managing and the ones that are either in your strategy. So on Aave, in order to know how much you can withdraw, you basically need to find the balance of the corresponding aToken. So in our case, since we are deploying USDC, it will be the balance of the AUSDC contract, which is at this address. So first I'll add it to my contract. Okay, so it already knows. And the address seems correct. Yes. And what you want to do is fetch the balance of this contract. Then we also check all the assets that are idle within our strategy. So asset that balance at this, and we'll return the addition of both. Then we'll go into the optional functions. So you have the available withdrawal limits. So on Aave, that does not seem to have any withdrawal limit. So we'll leave it at type 3 to 256.max. Same for the deposit limits. And the last function that there is the 10 function as well that we could implement, but for the sake of simplicity, I'll not do it. And since I didn't implement this function, I'll return false all the time. Yeah, and the last function that we should implement is the emergency withdraw function, which is basically the same rationale as the freefund function. And now what you can do is try to run the test. And obviously I haven't, okay, I know what's the problem. It should be external and not public. And now if the test pass, which they are passing, which is good. So this will tell you that basically you're on the right way if the tests are passing, because we do have, as I said earlier, some fork tests, and we are checking whether the strategy was profitable and whether some shares were minted to the donation address. So this is a good sign that you're on the right way, but still every strategy behaves differently. So we strongly advise you to create more tests. And that's about it for the presentation, the live coding presentation. And if you have any question, you can reach out to me on Discord or even on Twitter at SchemoAave. That's my name. And Nico
awesome.
is back.
Thank you so much, Maxime.
Yeah, sure.
Appreciate. Yeah, that was a very in-depth workshop. It's gonna be available for every one of you to review on YouTube. If you have any questions, please submit them here on the X broadcast. There you go. But yeah, excited for this. This is completely fresh out of the oven for us. So we're really looking forward to see what you come up with. Maxime, maybe are there any let's say places where, or like any tips for hackers that you might have, maybe things that they should pay special attention to when building yield donating vaults? Since you've built it, maybe you have some some deeper idea of what that could be.
Yeah. I mean, to be honest, we made it so generic and so simple at the same time that I think we kind of try to avoid like shot in the foot while building them. But yeah, I'm not sure, honestly. I don't see I don't see anything what they should watch for. But what I can advise them to do is look at their test suite, because their test suite is quite extensive, so they can see what we are expecting as behaviors. And yeah, no, I don't see particular like thing that should watch for.
Nice. Yeah, no, that's awesome. I think all the resources that we will have available later today are going to be also super useful for you. Also, make sure to take a look. These are going to be added primarily to our hacker manual, but of course, we're going to be sharing it on our Telegram group chat. For those who are joining new in the broadcast, I'm putting it in the chat once again for you to join. And also make sure to check out the hackathon page. We have listed the prices, and this workshop is going to be very key for tackling many of them. So make sure to check the folio page to sign up to the hackathon and check out the prices. We have a question from him. That is, are we also expect to implement the donation part?
No, so this part is part of the yield donating contract, and ideally, I don't think you should touch it. So what happened is what you need to implement is actually the harvest and report function. This one should return like all the assets that you are managing. And if you are implementing this function correctly, then the donation part should be done on its own. Like it's really as simple as what I showed earlier, just fetching on the yield source what you can withdraw, fetching the balance that you have as idle asset within your strategy, additioning the both, and then you should be good. The donation part should be working on its own.
Yeah, so if you manage to implement that technically, of course, that is enough, but you're still highly encouraged to donate to a public good if you can, because that will make it eligible for more prizes. We have a bunch of public goods related prizes. So, it's not expected, let's say, but it might give you a bunch more possibilities there. We are available if you'd like to share ideas and bounce ideas. Our mentors are available for you also in the group chat that we've created, and you can talk with them, find time to talk with them in the manual as well. Cool. Let's check if there are any more questions. I see that up next we're gonna have Graven, who is also gonna talk a little bit about donating via streams using Superfluid. So that's also gonna answer your question in some way, Kim. So yeah, I don't see any more questions here from the audience. But yeah, so the main thing here is to help us build some more yield donating strategies, as Maxime said, and there's really a plethora of options that you have when exploring the DeFi space. Just make sure to adjust the risk. Let's say keep the use case in mind. I think that's going to be quite important. But other than that, it's pretty much free for you to implement. What else? Any tips? Any final remarks you'd like to add, Maxime?
No, I mean, I would say just I guess have fun. Yeah, maybe like try to implement some exotic stuff. Like, for example, some cool new protocols. It will be interesting to see how strategies are working with. I'm thinking of, for example, Euler or Fluid, even Uniswap. I think we could do some cool stuff with the hooks. Like maybe you could do some nice stuff there. And yeah, feel free to reach out to us on Discord or on Twitter. Always happy to help if you have any questions. But yeah, I think that's it.
Oh, awesome. Thank you so much, Maxime. That was an awesome workshop. And yeah, as you said, our mentors are available on Telegram. You can find them with a tag next to them regarding what project they're part of. So you can ask questions directly if any doubts come up. But those tips on like some ideas of exotic protocols, let's say, I think can be super interesting. As you know, there is most creative use bounty, so probably those will go into that category. So thanks for sharing those tips, Maxime.
Sure, my pleasure.